All right, let's work on chapter 13. What do we have? Fitting a straight line to a set of data yields that following prediction line. Complete A through C. Okay, let's work A through C. So what do we have here? A. Interpret the meaning of y-intercept B0. First of all, let me write down that y we've had is equal b0 plus b1x. That's a regular formula. Let me, of prediction. Okay. And it should remind you the formula from algebra, formula for intercept and slope. Mx plus b, right? Where b is your available term, it's b0, and m is equal b1. Yes? Okay. So let's see what interpretation we need to give. Interpret the meaning of y-intercept b0. b0, it was available term, remember? Choose correct answer. So we have to have, first of all, the case where x is equal 0, because when x is equal 0, y hat is equal our available term b0. And plus our available term is equal 9, right? 9 plus 4x. 4 is a slope, 9 is our available term. So which means A and D are, no, only A is falling out. So one out of B, C, or D can be the true answer. Let's read it. So the y-intercept B0 equal 9 implies that average value equal 9 is 9. That's not true. It will be equal, the average value will be equal 9 only when x is equal 0, and that's what we need to find. Here it is, D, I see. The y-intercept b0 equal 9 implies when the value of x is equal 0, then the mean value of y is equal 9. There we go. Otherwise, look at the algebraically, x has to be 0, so 4 times 0, and y hat is equal 9. So x has to be 0 to apply average value, average mean, the average value of y equal 9. Next one. So question number B, what do we have here? Interpret the meaning. Now we need to do interpretation of slope. All right, so our slope is 4, right? So wherever this A is falling out, because it says 9, so B, C, and D can be. The slope b1 equal 4 implies that each increase of 1 unit in x, the value of y is expected to increase by 4 units. This is the answer. Yes, because we have slope positive, right? Plus 4. So for every the 1 unit change of x, unit of y is going to increase by 4. Slope is 4. Okay, it's going to be B. C is not going to be because it says decrease by 4. When would be the case of C true? When I would have minus 4x1. Okay, and the D is a nonsense. It's not for our case. Okay, moving to next one. So when x is equal 4, how much is going to be? Very easy. So 9 plus 4x. We have, I have is 9 plus 4x. If x is equal 4, we are getting 9 plus 4 times 4. and it's going to be 16 plus 9 is 25. Okay, moving to next question, question number 2. Fitting a straight line to a set of data yields the prediction of y yj is equal 2 plus 5x. The values of x is used to find prediction line from 2 to 23. Okay, so should the model be used to predict the mean value of y when x is equal 3? Because x is equal 3 is fitting. It says x used to find prediction line for age range between 2 and 23, then 3 should fit, right? We put in the yes. Next one, it's asking negative 3. I say no, because negative 3 doesn't fit the range 2 and 23. And then last one, 0. A, B, yeah, this is C. Doesn't fit, because 0 doesn't fit in between 2 and 23. And D, 22. 22, yes, fit, because it's up to 23 hour range. Okay, moving to question number 2. What do we have? Oh, it's a similar question. That's exactly what I was talking about. It was why it's gonna decrease by 0.4. Okay, the y-intercept B0 is equal 15, so it's going to be between A, C, and D. Implies that average, no. When x is equal 0, the mean value of y, no. Of y is equal, yeah, negative 0.4, that's it. Mean value is, for this specific case, mean value when B0 is equal, oh, it has to be 15, A, C, and D. Okay, I'm sorry, I didn't pay attention. So is 15, then the value x is 0, the mean value is 15. Okay. The y-intercept is 15, okay, implies that when the value of x is equal 0, then the value of mean value of y is equal 15. Correct. When x is 0, it equals 0, the 15. Okay, very good. Next one. B. So what do we have? The slope B1 is 15. No, slope is negative 0.4, so it's either C or D. So implies that average of y is negative 0.4. That's not the case. So the slope B1 is equal negative 0.4, implies that each increase of 1 unit in x, the value of y is estimated to decrease by 0.4. That is the case. But it's take as an algebra. B1 is negative 0.4. When one at the unit increase for x, the y is estimated to decrease because its slope is negative, right? So graph is decreasing. And we go for C. We need to calculate x is equal 5. So if we plug here, x time 5 times 0.4, it's going to be 2. And since negative 2, 15 minus 2 is going to be 13. Okay, moving to question number 4. So what do we have? Scatter plot. Find the graph below. All right, we are going to build a scatter plot. So for this case, for scatter plot, we are going to use calculator, and you have it in announcement on Blackboard. This is the calculator here. Okay, X and Y. So the easiest way is to copy to Excel. Let me see if I can copy to Excel and it will open for me. If not, the okay, looks like it's downloading here. Opening it. There in Excel, and then I'm going to copy this data. Okay, copy. Okay, we copied and now we paste it. I will paste X here. Paste. There we go. And then I'm going to copy the second one. This one. Copy. Good job, iPad. I thought it won't work, but it's working just fine. So, downloading, paste. All right. And I'm going to use here calculate. So here it gave me a regression line, but I will use in somewhere else, some other problem. But here is my scatter plot. This is how it looks, scatter plot. So I'm going to find a scatter plot that looks like this, without line. Line is you're supposed to do imaginary line. So I'm going to remember outliers here, and let me see if I can figure it out, which one it's gonna be. Okay, going here, closing. It's changed. Okay, it's not gonna be the same anymore. But anyway, at least you already know, and you have to find which one is gonna be similar. Okay, I'm just taking out of nowhere, let's say this one. Let me see if I'll guess it's right or wrong. Okay, one more time. This one. Okay, that was pure guesstimate. All right, now we are going to solve the second question. Let's find out what's happening here. So, assuming a linear relation, use the least square method to compute the regression coefficient B0 and B1. Okay, that's, I can show you from here. See here, y hat is equal 1.33682 minus in this case, although it won't match anymore because it changed it, but that's how we're gonna get negative 351134. That's gonna be your regression. That's your slope. and 1.3368 is going to be your intercept. Okay, so using this number, I'm just wondering where is your x here, why it doesn't show x. Oh, yeah, here it is. Y hat here, let me zoom it in this table under scatter plot. You can open here. Here is calculate your line. Y hat is equal 1.336. So we see where x is. That means 1.33 is a slope, and negative 35.11344 is your intercept. So which is going to be b0, negative 35, it's going to be b0, and 1.33 whatever, it's going to be your 2 minutes not using, and it's already changing everything. All right, so I'm just let's move to number 4. Do you already number 5? You already know what to plug in there. Okay. So we are moving to question number 5. Okay, it's the same thing. You are going to work the same way. Copy, paste, find the scatter plot, and then based on equation you will see below scatter plot, that will be your B0. Okay. And let me open the answer for this case so I can explain to you. This B0, B1 you will get from this calculator and from this equation, obviously. And here I saw you have more questions here. Interpret the meaning of the slope B1 in the problem. Select the correct choice and fill up the case. So in our case, it's going to be B1 is 2.4. Why is it 240? It's increase of tuition $100. Okay, 2.4 times 100. So your slope, since it's tuition, for each tuition $100, the mean starting salary upon graduation is expected to increase by 240. So this dollar amount tuition, you multiply by this slope, and you will get explanation for mean salary that upon graduation is expected to increase by $240. Now, and predict the mean starting salary upon graduation for program, and it's gonna be, we're going to plug these values into our equation. Let's do it. Let me keep this number so we can solve it. 1 second. I want to take this picture of this number so we can work here. So we have our B0 is 11,742, and B1 is 2.4. Okay, and we need to find what was that? Let me look one more time. Predict the mean starting per year. Okay, 59,418. 59,418. X is equal 59,418. So we are applying in this formula. All right, and let's see what we're gonna get. So we are getting B0, 11,742 plus 2.4 times 59,418, because instead of X. And we are getting, let me see, 2.4 times 59418. I'm getting 142,603.2 and plus 11,742, and I'm getting 154,345.2. Let's go back. 154,345.2. The answer is open, so let's see how much. 131,133. Well, let's double check. Why is it getting this way? Duh, it's negative. B0 is negative, of course. Is here is negative, which means I'm going to do 11,742 and then one more 11,742, 138. I'm getting 130, 861.2. Let me see if it was it. Okay, well, I need to do it over. I'll just try to maneuver not to calculate again. Let's go over one more time. 2.4 times 59418. I'm getting 142,603. Okay, and minus 11,742. I got 130,861. 130,861. That is very weird. But I assure you, calculation is correct. So if something is wrong, just if you won't get the answer, just let me know. I'll give you credit for that. Okay? Moving to E, what insight can be obtained about relationship between program per year tuition and starting salary upon graduation? So the mean starting salary upon graduation tend to be higher among programs with higher per year tuition. Having a higher mean starting salary upon graduation result in a lower program year tuition. That cannot be the case between program per year tuition and starting salary. So let's see, starting salary 131 and tuition, it's upon 100, the mean starting salary upon graduation expected to increase to 140. Yes, that's the answer in the C. So the mean starting salary upon graduation tend to be higher among programs with higher per year tuition. Okay, so question number 6. So how to interpret coefficient of determination? So first of all, what is coefficient of determination? Coefficient of determination is a measure that used to analyze and figure out how well the model predict the outcome. So how close to the truth is the prediction? That's what it is. And coefficient of determination, which we write down R squared, is usually runs between number 0 and 1. and it shows how well statistical model predict the outcome. All right, so in our case, determination is going to be that since we have r squared equals 0.17, which means 17%, because 0.17 is a decimal notation, where we have 17d. Interpretation is that 17% of variation in the dependent variable is y from algebra based on equation y is equal mx plus b. X is independent variable and y is dependent variable. Y is always depends on x. So the variation in the dependent variable can be explained by variation in the independent variable. Okay, so it's going to be D. So first let's understand what is autocorrelation of the residual. Autocorrelation, it's a mathematical representation of the degree of similarity between given time and like the versus of itself, version of itself. So practically degree of correlation of variables over time. Okay, so let's see, are they correlated? Does not appear autocorrelation. I would say no, it appears strong positive autocorrelation. Yes. Okay, there we go. Okay, I'm done. See you in next video. Let's check. Good job. Now we are moving to question number 7. So, what do we have here? If SSR is equal 32 and SSE equal 8, determine SST, then compute the coefficient of determination R squared and interpret the meaning. Okay, so we have SSR 32, let me write down. And what else I had? SSE 8. Okay, so we need to determine SST, right? Yes, SST. So SST, it's a total sum of squares is equal SSR, which is, to remind you, SSR is the regression sum of square. Regression sum of squares plus SSE, and SSE is a error sum of square. E, error sum of square, R, regression sum of square. Okay, so, and it's going to be equal accordingly. SST, it's going to be equal 32 plus 8, and it's going to be equal 40. Let's write down. Very nice. Next one, we need to find rho square coefficient of determination. So there is a formula for coefficient determination, R squared, that is equal SSR, it's a regression sum of square, divided by SST, total sum of squared. And it's going to be SSR, we have 32, total is 40. So how much it's going to be? 32 by 40, it's going to be 0 point, and 340, it's going to be by 4 is 8. So let me put the answer 0 0.8. Very good. Okay, so next we are going to do, all right, next we are going to do explanation. So interpret the meaning of R squared, choose the correct answer below. So based on this division, SSR over SST, we can identify that the coefficient of determination, it's a proportion of variation in y that is explained by variation in the independent variable x, so y over x. Okay, so from the 0 0.8 we are going to get it in decimal notation, it's going to be 80%. Okay, it's in our case it's going to be 80%. So let's see what answer we're going to get. I see here R squared times 100% because we get in the decimal notation and we did multiply by 100. So it's going to be, it means that R squared times 100% of the variation in the dependent variable can explain the variation by the variation in the independent variable. Yes, it's a proportion dependent by independent. And we multiply by 100% to get our percentage. Okay. Very good question. Moving to number 8. So what do we have to do here? Number 8, SSR is given 69, SST 92. Well, we know what to do, right? SSR 69 and SST 92, right? Let me double check. Is 69 and 92. Okay, if I divide, (69) divided by 92, I'm getting 0.75. Okay, hold on, 0.75. Okay, so and the explanation to this, it's clear, similar. R squared times 100, right? Okay, we have to multiply by 100 of the variation in dependent variable that can be explained by the variable of the independent variable. Okay, let's check it. All right, moving to question number 9. So what do we have here? We said if SSR 120, why is it impossible for SST being 110? Because SSR is a part of SST. That's why the piece that is part of SST cannot be more than total, right? So it is impossible because SST equal SSR plus SST and sum of square cannot be negative. Okay. Did I choose the wrong answer? Hold on, let me see. Cannot be I didn't pay attention or what? It's impossible because SSE is equal, hold on, SST is equal SSR. I chose SSE. I'm sorry, I didn't pay attention. SST is the total, is equal regression sum of squared plus error, the sum of squared. Okay, we got it. Number 10. Well, we need to find a coefficient of determination. Well, let's see how we're gonna solve this problem. So, in an attempt to develop a model of wine quality as judged by wine expert, data of alcohol content and wine quality was collected from a variant of a particular wine. From a sample of 12 wines, a model was created in the percentage of alcohol to predict wine quality. For those SSR, meaning regression, the square is equal 20,000 to, let me write down SSR regression sum of squares. And then what else we have? SST 28,874. 28,874. This is total sum of squared. Oops. And what else? Use the information to complete part A through part C. And we have wine is 12. So n is equal 12. Okay, we need to find coefficient of determination. So remind you, coefficient of determination is equal SSR over SST, which means 20,002. We divide by 28,874. Let me divide it. So 20,002 dividing by 28,874, and I'm getting 0.6927, and that's enough. So 0.693 rounding. 0.693 coefficient of determination. Okay, very good. What does that mean? That means that 16, that's a decimal notation, 0.693, that means 69.3% of the variation in wine quality can be explained by the variation of alcohol content, right? Here it is, alcohol content. Okay, well, let's check, see what we get. Excellent. Moving to B, we need to find B. Let's see what we need to do there. So determine the standard error of the estimate, SYX. Standard error of the estimate, SYX. Estimate, let me, with red color, that's a formula, is equal SSE over n minus 2, n square root. Okay, now how much is our SSE? We are not given, we don't know our SSE, so we need to find out. SSE is equal SST, total sum of squared. So error sum of squared, it's a total sum of squared minus regression sum of squared. Okay, my SST was 28,000. Hold on. Here it is. 28,874 minus 20,002, right? Because if total consists of regression plus error, accordingly, error gonna be total minus regression sum of squared. And this is gonna be equal, let me see. So 4 minus 2 is 2. Here is gonna be 7, 8, 8,872. Okay, and from there we are going to plug SYX is equal square root 8,872 divided by n was 12, right? In our case, here it is. 12 binds 12 minus 2. So it's going to be equal square root divided by 10. So 887.2, right? Hold on. Yeah. And how much is going to be 8,000? Hold. Wait. 1, 2, 3, 4. 2, 7, 8, 8,000. Okay, 887. Okay, let's take square root. Let me see. 887.2, and if I take square root, I'm getting 29. And I have 7859. How many decimals it's gonna take? Let me see. Round to 4 decimals. Okay, well then we put all 4 decimals. 29.7859. Okay, nice work. So what is next? How useful do you think regression model is for predicting wine quality? Okay, let me see which. Obviously it's going to be by, if it's 69 by 69.3%, that's pretty good, huh? So it's close to 70%. So it is going to be very useful for predicting wine quality. Let me see how many we have. Very okay, either C or A, very useful. Okay, because how much is the value of our coefficient of determination? Remember, it's run from 0 to 1, right? So in case A, it says because the coefficient of determination is close to 1, and C says it's very useful because coefficient of determination close to 0. If it's close to 0, it's nothing to predict, so it's going to be close to 1, right? 100%. So this is going to be our answer, because 70% is close to 100% then to 0. Question number 11. Okay, you can find out r squared. We already did it. Very, very similar, this problem. Number 12. Okay, what do we have here? The result shown that to the right provide x residual and residual. Okay, so this is a result of residuals. We need to find out, is this scatter plot show some positive or negative line? No, it's completely a random spread, right? So where do we have random spread? Here. And good job. And we have another one, last one. So this one looks like a V shape, right? So let's see which one will be closed. Decreasing variation, no, this is not increasing also. Cyclical, no, a distinct curved pattern, this one. There we go. And that's it. Oh, wait a minute. We're going to do question number 14. We have one more question. So first of all, what we're gonna do, you need again, this is time period and residual. Based on this data, you're gonna find out which graph is matching. So time period is gonna be your x, and residual gonna be your y. So you can check, let's say the last one, 10 and 8, when x is equal 10, y is equal 8. Do we have here 10? At the a, I'm looking, y is not equal 8. Negative 10, negative 9, negative, so it's something negative. Okay, which one? We have to be higher. Looks like this one. This is 9, D, 0, 1, 2, 4, 6, 8. No. Okay, or you either can go by these points, or you can place in the, to get scatter plot, place in the regular the regression line calculator, remember? So your time period will be x and residual will be y, and it will give you your scatter plot. And I will open now, so to see, well, it's going to change the data. Yeah, it changed the data, see? Last one, 10 and negative 3. So what do we have here? If I wouldn't know, based on what I see, it's going to be chaos, because from 1 through 10, it's increasing time period, and here get plus, minus, 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 plus, minus, it's chaos. Let me take, just for the heck of it, another similar question without guessing the answer, without having the answer, and based on results, we can see. Look, as its time period is increasing till 10, look at the residual. From negative 10, it's smoothly growing, so it's going to be positively at the line. I would bet it's going to be this one, increasing. See? You want to, okay, let's continue this one. What else do we have here? So we can say that increasing linear relationship exists. That is very, very true. Anything else? Based on result in A, which is scatter plot, what conclusion we can say? So